Can you imagine a world without much of the technology that we enjoy today, including cell phones and microwaves? This would be the world today if Maxwell's equations didn't exist. Let's start by defining some entities that are important to understand before talking about the equations themselves. Since the beginning of the universe, a property has existed that we now call charge. There are two types of charge, negative and positive. Like charges repel, and opposite charges attract. Charges can also feel each other from a distance. This is because those charges create electric fields throughout space. Those electric fields, propagating at the speed of light, are a way to describe a force due to a charge at a remote location. In certain circumstances, those electric fields created by charge are able to move other charges. Those moving charges are called electric currents. Those electric currents create magnetic fields. This is stated by the Biot-Savart law. Having introduced some of the physics that influenced Maxwell, now we move on to the equations themselves. Carl Gauss, a German mathematician, found a really cool way to describe the characteristics of magnetic and electric fields by introducing models that help us predict the consequences of these fields. Imagine you have an unknown charge inside of an imaginary bubble. You can predict the amount of net charge inside by looking at the amount of electric field that pokes through the bubble. If the electric field pokes out of the bubble, you know the net charge must be positive. If the electric field pokes into the bubble, you know it must be negative. Magnetic fields are a bit different. All the field that pokes out of the bubble must also poke into the bubble. This is because every magnet has a north and south pole, positive and negative. Michael Faraday was also able to figure out that changing magnetic fields can produce electric fields perpendicular to the magnetic field. These electric fields have a twisty shape, unlike the ones caused by charge. Ampere found a way to describe how to calculate magnetic field due to a current through some region in space. Maxwell figured out another way to describe this. He figured out that there didn't even need to be a current to create a magnetic field, just a displacement current, also known as a changing electric field. Using Gauss, Faraday, and Ampere's work, Maxwell was able to figure out that light is an electromagnetic wave. He was also able to calculate the speed of light and figure out that there are an infinite number of electromagnetic waves using these three scientists' work, along with the work of Coulomb and Oersted. So, the next time you go to warm something up in the microwave, or to turn on a light, or to even look through a telescope, think of Maxwell's equations and how his valuable conclusions enable us to do all of this.